Okay, so now we are supposed to solve locus problem. Px dash y dash, so distance ps upon pm. Let us put perpendicular on directrix. Let that be m, and this distance is ps. So ps upon pm is equal to E, implies ps square is equal to E square pm square. Why square? Because it is good to deal with squares in case of distances to avoid the radical sign. Distance ps x dash uh, x dash minus ae bracket square plus y dash minus 0 bracket square, that is ps dash, is equal to e square distance of this from this line, distance of x dash y dash from this line is easy, na? Distance of x dash y dash from this line is, it's on parallel to x axis, therefore a upon e minus x dash bracket square. So this is the geometric condition. Of course, you have to write let px dash y dash belong to desired locus, then this is geometric condition, and then we simplify. So once we simplify, we get a nice expression. Let us x dash square minus 2a x dash plus a square e square plus y dash square is equal to a square e square multiplied by e square a square minus 2 a e x dash plus x dash square plus e square x dash square. We find that these terms are common, and if we take everything to LHS, let us see what we can do best. बरोबर चाललंय ना सगळं? So x dash square minus, now e is lesser than 1, so it is good to write x dash square inside bracket 1 minus e square plus y dash square inside bracket 1, there is no other y dash square here, good, is equal to, let us put there is no x dash term, so it is good. About good part of that is there is no x dash term, a square is remaining, this is done, this is done, minus a square is square, so I can take a square is square common, 1 minus e square. Are you there? So it, instead of carrying this load, we can write x dash square upon a square plus y dash square upon a square into 1 minus e square is equal to 1. And then we will say, of course, replacing x dash by x and y dash by y, we get desired locus. X square upon a square plus y square upon a square inside bracket 1 minus e square is equal to 1. Let a square is into 1 minus e square is equal to b square. We introduce new quantity called b, which is a square into 1 minus e square. So because e is less than 1, this quantity is going to be less than 1, therefore b square is supposed to be less than a square. Okay, and hence we get a desired expression. This is ellipse. Yes, this is ellipse. Okay. The moment you get the standard equation of ellipse, you should start analyzing the equation for following things. Number one, what is the intersection of x-axis? Put y is equal to 0, you get the intersection of x-axis. We already knew that a and a dash are part of this curve. Put x is equal to 0, we get plus or minus b. And we know that eccentricity is less than 1, therefore b is smaller than a. So let us make b here somewhere and opposite of b here. So these are the 2 points which are going to be on the curve. So p is on the curve, so I can join this p. A is on the curve, so I can join a. Others. Therefore, next analysis that we are supposed to do is 3. The way put x is equal to 0, y is equal to 0, we will put x goes to positive infinity, plus infinity. Put, or maybe let x tends to plus infinity. What happens to this equation? Why is this b shifted? Done something to that expression. Okay. If x takes very high values, it is not allowed. X cannot take very high values as far as this expression is concerned. Because eventually summation of two squares is supposed to be 1. So let x tend to infinity, not possible. Okay, not possible. Then what is the maximum value of x? What is maximum value of x that can be taken is equal to maximum value of x that can be taken is equal to a, and minimum value of x is equal to minus a. So this is the extent of this particular curve. The curve is not going to go beyond plus a, not available, and less than minus a, not available. So it is bounded, it is finite curve, it is there opposite of us, we can see it. So x tends to infinity, not possible. Similarly, we can analyze for y and we realize let y tend to infinity. Now of course, if it was giving you some result, you should have taken x also to negative infinity, y also to negative. But we come to know immediately that it is a extent of this curve is not much and it is closed. So again here bigger than, okay, this coordinate is 0 comma b, this coordinate is 0 comma opposite of b. Okay, beyond this, above the curve is not available, and below this curve is not available. So extent of this curve, I am writing y is equal to plus b, y is equal to minus. That is the another analysis that you should do. Okay. Next, in case of hyperbola, you will do this analysis, but because this is for the first time, I am telling you how to go about it. Fifth analysis that I can do is p x dash y dash belong to ellipse. No, ellipse belongs to ellipse. Is cube opposite dash comma y dash belong to E question mark. Okay, let us go back to equation and check what happens. 56%. If we put opposite of x and y dash, we will get the same equation. Okay, so yes, if you put opposite of x instead of x, you belong to the curve. Curve is symmetric about y-axis. Okay. Good. Similarly, if you put x dash comma opposite of y dash, you will find yes, 6. Curve is symmetric about x-axis. Good. Moreover, if you put opposite of x comma opposite of y, still you are okay. That means curve is symmetric about origin. Very good. So, sir, this curve is very symmetric. It is symmetric about x-axis, symmetric about y-axis, symmetric about origin, and therefore now we can really complete the curve and it is going to look like this. Symmetric with x-axis. And the whole curve is symmetric with respect to y-axis. It is difficult to draw, but smooth everywhere. Okay. See, if this curve was going towards infinity for large values of x, value of y is available, then we should have checked it for asymptotes if that is tangent at infinity or etc. But in the present case, we cannot check that because the entire curve is closed, symmetric, and is in front of us. Oh, but then there is still some non-symmetric element present in this diagram, which is D. If the entire curve is symmetric, good, there will exist one more focus S dash, symmetric to S. Because of symmetry of the curve, there will exist one more focus S dash, and whose coordinates will be exactly opposite of that of S, minus AE comma 0. And there will exist one more directrix. जरा लांब झाली का? D dash, whose equation is going to be x plus a over e is equal to 0, and this point is going to be z dash, which is opposite of a upon e comma 0. Now the story is complete. Now it is completely symmetric. So do you realize that we suddenly found out one more focus and one more directrix, because whatever happens to this focus and this directrix to the right side, having positive side of x-axis, exactly similar thing will happen to the negative side of x-axis because of the symmetry of the diagram. Good. Very good. And therefore, now we let go back to figure out the properties. So in terms of, now can we write down the eccentricity in terms of, so 8 e square is equal to, what is our e? B square is equal to a square inside bracket 1 minus e square. Therefore, e square is equal to, can you tell me what is e square is equal to? B square, sorry, a square minus b square upon s. It has to be positive and less than 1. These things are required to be remembered, because while problem solving you will require this. Either b square is equal to a square into 1 minus e square, you have to remember, or e square is equal to this. This is how you will find out the eccentricity of ellipse. Now, a dash is called major axis. B dash is called minor axis. Find 10. Let P be x dash comma y dash. Find PS, focal distance. Distance of point P on ellipse from focus. Also find P S dash. E times PM. So E times PM. PM, if you want to keep it positive, then it is what was this? E upon A upon E comma 0 na. So A upon E comma 0 minus X dash, then in this quantity is going to be positive, which is A minus EX dash, that is your PS, and PS dash is going to be अरे डायग्राम इकडे कुठे आली, पूर्ण डायग्राम का नाही आली, जुनं जे सिलेक्ट केलं होतं ते झालंय. बरं ठीक आहे. PS dash is going to be E times PM dash. Okay, now you deal with the second directrix. So PS dash is equal to E times PM dash, which is equal to E times what? Distance between them. You are supposed to take bigger minus smaller. So bigger is X dash, minus minus smaller is A upon E plus A upon E, which is equal to A plus EX dash. This is focal distance. Oh, focal distances are so nice. Therefore, 11 PS plus PS dash is equal to 2A. This is the most important property of ellipse. Ellipse is a locus of point which keeps summation of distances from two foci equal. Always. LL dash is a latus rectum, which is a chord perpendicular to x-axis passing through focus. Find length of latus rectum. LL dash. Okay. Meanwhile, I will replace this diagram by the other diagram. Delete. I should make it small and then do these activities so that I have better control on that. Okay. Copy this. So check. Copy. Copy. Paste. Not bad. LL dash is supposed to be your latus rectum. Okay, length of latus rectum is 2b square upon A. You can easily find out because you can find out the coordinate, y coordinate of L and y coordinate of L dash, add them, you will get length of latus rectum. Now the parameterization. How are we going to parameterize the ellipse? You can show me your parameterization of ellipse, then I will show you the standard parameterization of ellipse. As far as parameterization is concerned, if we just try to get the algebraic parameterization of x square upon a square plus y square upon b square is equal to 1, then it is not going to really help us, because with parameterization we expect our algebra to be simple. Like you have experienced it in case of parabola, the parameter t makes your life easy, because slope of tangent, slope of normal in terms of t are absolutely simple, focal chord, etc. So if we have some algebraic simplification, algebraic parameterization of this using parameter t, of course it will work. Every parameterization is going to be correct, provided it satisfies this equation. But then here it is summation of two squares. Summation of two squares equal to 1 tells us use of trigonometry in parameterization. Therefore, we have again two choices. I can call x is equal to a sine theta and y is equal to b cos theta. And another choice is I can call x is equal to a cos theta, y is equal to b sine theta. So which one would we adopt? I mean, which one we should adopt? We should adopt second one, because in the definition of cos theta you are supposed to look at x-axis and this is x coordinate. That is easy. This parameterization also will work, but this is little difficult, because in x coordinate goes with sine, then it is little trouble. And moreover, our circle parameterization x square plus y square is equal to a square, x is equal to a cos theta and y is equal to a sin theta. That was there in circle, parameterization of circle. So in line with that, the only change which is happening in case of ellipse is b instead of a over here. So if b is equal to a, we are supposed to say that it is a circle. And yes, ellipse is a circle if b is equal to a. We will see what happens if b becomes a, and it is going to be a limiting case, and we will discuss about that little later. But the final parameterization, which is most general, most commonly used parameterization, is a cos theta comma b sin theta. Oh, if it is a cos theta comma b sin theta, then you circle here with radius small a, and you are applying pressure in this direction to the circle. Every point on the circle is correspondingly getting compressed to become this point, and then this ratio is going to be b upon a. So ellipse is a uniform compression of circle in the ratio b upon a in the direction of y-axis, I will say. So it is understood that you are supposed to compress the above x-axis part by b upon a to become ellipse, and exactly same you have to compress by the ratio b upon a, the smaller part of the circle, to get the ellipse symmetric. So it's a uniform compression, and therefore what is this our parameter we need to identify, because it is going to be otherwise dangerous for us to use that parameterization. Now your theta, for different values of theta, you are saying that you will get different points on the line, on the ellipse. This green is bad. Let me take black. So let me explain you Every time it takes, but whenever I draw circle, it doesn't become circle. This is your circle with a comma 0, opposite of a comma 0. This is most important discussion because otherwise you will make so many errors. Now, let me draw ellipse. Ellipse is something like this. And then we are saying that it's a uniform compression. Corresponding point on circle will be a cos theta comma b sin theta. Understand this. Point on the circle is a cos theta b sin theta, and you are compressing the x coordinate of this point will continue to remain same, a cos theta, because it is a vertical compression, and y coordinate is अरे वरचा तो a पाहिजे ना. This is a cos theta. That is the point on circle, and you are compressing it by b by a, therefore it becomes b sin theta as y coordinate on ellipse. Therefore, the theta you are talking about here, which is the theta that you are talking about, E, which is the angle, where is the measure of that angle which you need to really measure and get the point. So this is the theta. This is angle theta that you are talking about. This is theta and this is not. Understand the difference. This is alpha. Alpha is not equal to theta. And your eccentric angle. So this is called eccentric angle. Theta is called eccentric angle. Okay, because it has something to do with the eccentricity of ellipse, so it is called eccentric angle. And if you want to find out a point on ellipse, you might as well draw circle, construct that eccentric angle on the circle, you go on the circle with that eccentric angle and vertically come down by b by a to get the point on ellipse. That should be the procedure. So in ellipse, if you draw a radius segment, something like this is x-axis, and if you say coordinate of this is a cos theta comma b sin theta, and if you say that this angle is theta, you are more than 100% wrong. It is eccentric angle. Eccentric angle is somewhere else. But then the calculations, because of this parameter, I understand the parameterization should be simple. Yes, it should be simple for algebraic calculations. Location of that point geometrically, you will require to do hardly any time, but you will have to deal with algebra of that parameterization more frequently. Therefore, this is the best way to go about it. Theta is a parameter, and theta varies from 0 to 2 pi. You get the complete ellipse. 0 to 2 pi. All values of 0 to 2 pi will give you entire ellipse. Note down all these things. The circle through which you are going to locate your point geometrically on ellipse is called auxiliary circle. Find the equation of tangent. What is the number now? What is the number going on? 15. Find the equation of tangent. or write the equation, because you know already how to find. Write the equation of tangent to standard ellipse x square upon a square plus y square upon b square is equal to 1 at P1 x1 y1 belonging to ellipse. So okay, I will help. X1 upon a square plus y1 upon b square is equal to 1. Write equation of tangent at p theta. Now you write this and immediately you have to remember it. What is the parametric equation of tangent? This is the wrong diagram that I have drawn. Huh? This is not correct. Not correct. That is what I was trying to explain you, that if you do it like this, you consider this as theta and your ellipse is like this, then it is not correct. That is what I was saying here. What is correct is this. This is correct. So you have to go to auxiliary circle, get that point and go down by b by a ratio to get the point on ellipse. Okay, replacing x1 by a cos theta and y1 by b sin theta, you get equation of tangent in terms of theta looking like this: x cos theta upon a plus y cos theta upon b is equal to 1. Now you find out equation of chord p1 x1 y1 p2 x2 y2. They belong to ellipse. I think we have done it earlier in several times. It is going to be x minus x1 into x1 plus x2 upon a square plus y minus y1 into y1 plus y2 upon b square is equal to 0. That is what is your equation of chord. And it is easy to remember it like this because you are maintaining positions of a square and b square in their places. So what you need to remember in case of tangent, that x1 in the numerator, and this is by now it is very easy. And in case of chord, it is this, these two brackets. Okay, so of course you'll have to put in some energy to remember that, but then remembering should be easy. Therefore, your express, you cross multiply this and put 10 different terms. It is, how are you going to remember it? Impossible. Next.
सर
Yes.
सर मग याचा उपयोग काय आहे? म्हणजे आपल्याला 2 पॉईंट दिले की लाईनचे इक्वेशन तसे काढता येतच ना म्हणजे
आपण गणित सोडू तेव्हा कळणार आपल्याला इक्वेशनचे उपयोग काय. आता कसं कळणार? 2 पॉईंट दिलं तर इक्वेशन ऑफ लाईन काढता येणार आहे. ते 2 पॉईंट इलिप्स वर असतील ते चेक करायला पाहिजे. बरोबर आहे थिअरॉटिकली. But we will require, we are trying to develop our tools. We cannot afford to spend time in developing equation of chord later on while solving problems. म्हणून आता तुला एक स्ट्रेट लाईन दिली, आणि सांगितलं असं आहे, this straight line is passing through this point and the equation of line is known to me. It is going to be chord and this equation might be helpful to you to figure out what these x and y's should be coordinates. So काय उपयोग आहेत त्याचे. It will be useful several times. Find equation of chord p1 theta 1 p2 theta 2. Now it is the question of converting the x1 y1 equation into theta 1 theta 2. So eventually after simplification using trigonometric identities The answer that you are supposed to get is x upon a cos of theta 1 plus theta 2 upon 2 plus y upon b sine of theta 1 plus theta 2 upon 2 is equal to cos of theta 1 minus theta 2 upon. This is your equation of chord in terms of theta 1 and theta 2. 19. Find the point of intersection of tangents. P1 theta 1, P2 theta 2. You already know the equations of tangents at P theta 1 and theta 2. You are supposed to find out the point of intersection and then do some trigonometric simplification to get the final answer. And I think it is not that difficult. Therefore, the answer for this is a cos theta 1 plus theta 2 upon 2 whole divided by cos theta 1 minus theta 2 upon 2. That is your x coordinate, comma b sine theta 1 plus theta 2 upon 2 divided by cos theta 1 minus theta 2 upon 2. This is the point of intersection of tangent at theta 1 and theta 2.
So,
Hmm.
instead of doing that, we can also compare the coefficients of t equal to 0 and the above equation of chord.
Above equation of chord and equal to 0. Comparing coefficients, you get the point of intersection. I did not understand. What are you trying to say?